So this chapter is called Multiplying Rational Numbers, and this is chapter 5.3. So we've been learning a lot about rational numbers and what are they. And so a rational number we talked about being any number that can be written as a fraction. And so to multiply rational numbers, we're actually just going to focus on the fraction part. So we're going to learn how to multiply fractions. Now go ahead in your notes and take a minute and copy what you see here, and then we'll discuss it. So go ahead and pause me and copy this. Okay, so to multiply fractions, we're going to multiply the numerators and multiply the denominators. So here I have the symbols A times C and B times D will give me A times C over B times D. Now, as you can see, I multiply the numerators straight across, and then I multiply the denominators straight across. Okay? Now, it also makes a note where B and D cannot equal 0. Now, that's just saying that you can't have a 0 in the denominator because then you get an undefined number, and that's not good. So we just want to make sure that our denominator is not 0. That's all that fancy stuff means. Okay, so let's look at it with some numbers in there. So I have 1/3 times 2/5. Now we just talked about multiplying the numerators and multiplying the denominators, right? So then we have multiplying the numerators, we have 1 times 2 and 3 times 5. Now you just multiply these. All right, and then we get 1 times 2 is 2, and 3 times 5 is 15, which we have here. So we have 1/3 times 2/5 equals 2 over 15. Okay, now go ahead and put this example into your notes. And please remember, you also need to write the directions, because if you just have a bunch of numbers all over your notes, then sometimes you don't know where to reference. So don't forget to write your directions in your examples as well. Okay, so this one is 2/3 times 3/4. Okay, so remember when we multiply fractions, we multiply straight across. Okay, so this is actually turning out to be 2 times 3 over 3 times 4. I don't know how that just changed colors, but it's kind of cool. Yep, there we go. And so when I multiply straight across 2 times 3 and 3 times 4, I get 2 times 3 is 6 and 3 times 4 is 12. Now, if we can remember from last chapter, we learned how to simplify fractions. And if I simplify this, I can divide this side by 6 and divide this side by 6, and I get 1/2. Now, you can do it this way, or there's a tiny, simple trick I can show you. And this is called cross-simplifying. So if I had 2/3 times 3/4, just like this. Now, you can always, always, always do it this way, and then simplify at the very end, like we did here. But if you see this, what I can do is actually something called cross-simplifying. Now I can look here at the numbers that are across from each other. So 3 and 3 are, you see, they are across from each other. If they are able to reduce, that means one can go into the other. So 3 is common with 3. So 3 divided by 3 is 1, and I can simplify those both to 1. Now I also can cross-simplify, if you can believe it, the other one as well, 2 and 4. Now 2 can simplify to 1, and 4 can simplify to 2. Now when I multiply these together, I have 1 times 1, which is 1, and then 1 times 2, which is 2. And as you can see, I get the same answer. I just don't have to simplify at the very end. Okay, now you try this one. You can pause me if you'd like. Okay, so did you see that you could actually cross simplify in this one as well? This one I can cross simplify. Both of these have a 2 in common. So I could divide 4 by 2, which is 2, and I can divide 6 by 2, which is 3. Now I can come here and I can multiply 2 times 1, which is 2, and 7 times 3, which is 21. Remember, with multiplying fractions, you multiply straight across. Okay? Now you can cross simplify, but you can't cross multiply. Don't get that confused. Remember, it's straight across. Okay. Now I want you to try this one. And also, make sure that you notice the negative sign. Now, we talked about in our earlier chapter about having positives and negatives, and what happens when you multiply a negative times a positive. Think about that as you try this one. You can pause me if you want. Well, actually, I would like you to pause me. Pause me, work this one, and then come back. Okay, so as you can see, we can cross simplify here as well. So we have 3 and 12. Now, both of those have a 3 in common, so I can divide both of those by 3, and 3 divided by 3 is 1, and 12 divided by 3 is 4. Okay. Now, we also talked about, just a second ago, how we have a negative times a positive. And if you recall, a negative times a positive gives you a negative sign. All right? And then we come and we continue multiplying. 5 times 1 gives you a 5. And then we multiply the denominators. 4 times 8, which is 32. So our answer should be negative 5 over 32. Okay. Now we also have another type of fraction, which we learned a little bit about the other day, was a mixed number. Okay, now a mixed number has a whole number and a fraction. Okay, so in this case we have 1 2/5 times 2 1/2. And so we actually have to do a little bit of changing to the problem in order to solve it first. So we learned how to make these improper. So I have a 5 times a 1 and a 1 plus a 2. So 5 times 1 is 5. Add the 2 is 7. 7/5 times 2 times 2 is 4. Plus 1 is 5. So we now have 5 halves, right? So we look at this, and now I have 7/5 times 5 halves. Well, now this is more of a problem I could work with. All right, so I actually am going to multiply just like I was just doing. And this is actually going to be pretty simple because I can cross simplify this 5 with this 5 to make those 1. And I'm going to multiply just like normal. So 7 times 1 is 7. And 1 times 2 is 2. Now, I prefer to keep things in improper fractions, but this is also where you can make this 7 halves, excuse me, a mixed number. So you say, well, how many times can 2 go into 7? Well, 2 can go into 7 3 times with how many left over? Well, there's 1 left over because 3 times 2 is 6, and we're trying to get up to 7 here. And so we add 1, and our denominator remains the same. So I would accept either 7 halves or 3 1/2. It's really your preference, whichever you choose. Okay, now to throw a little bit of a curveball in there for you, we have some variables in this one. Now, we have been introducing ourselves a little bit slowly to some algebra, but this is definitely an algebra problem. So we are going to keep the same rules of multiplying fractions, and that is that we are going to multiply the numerators and multiply the denominators. So I'm going to write this a little bit differently than we were before. And I'm going to write it all out. So this is saying 2 times a times b squared, which is really b times b, all over b times d, which is written b times d. Now here I can really cross-simplify my, my variables. So I see that I have a b and a b in common. So I can actually just go ahead and cross those out and simplify that a little bit further. Now, is there anything else that I could simplify just looking at this problem? Well, in this case, no. There's nothing else that I can cross-simplify. The only ones that are in common are these b's. Okay, so we cross those out, and now to write it, I write 2 times a times b all over, well, we only have d left, so all over d, 2ab over d. Now I would like for you to try this algebraic fraction. Go ahead and pause me and try it on your own. Okay, so this one, we're going to follow the same steps. So we're going to do 4 times 18 times t times r over 9 times r times t times t. Okay, so we have 4 times 18 up here on the top, and we have a 9 on the bottom. So let's go ahead and get rid of our numbers first, because I can actually simplify here. All right, so here I have a 9 in the denominator, and I have an 18 up in the numerator. Well, what do you think is in common with 9 and 18? Well, 9 is, right? So I can cross-simplify that to a 1 and a 2. Okay, and then I can't really simplify anything with 9 and 4, so we're just going to leave the 4 just as is. All right, now let's look at our variables. Okay, so what variables do I have in common? Well, I have an r on the bottom and an r on the top. I also have a t on the top and a t on the bottom. All right, so we're just going to write what we have left. Well, we have a 4 times a 2, which is 8. And what's left on the bottom? Well, we've got a 1 here. We don't really have to write 1. It's just kind of assumed. And we have a t on the bottom. So really, my problem here is 8 over t. And how many of you guys got that? If you got it, give yourself a big round of applause. Okay. Now here are a couple extra example problems. And I would like you to try these now, and we will go over them. And I will check for them to be complete tomorrow in class. Good luck.